So first piece of vocabulary we're gonna talk about is critical point. So that is where your derivative is 0 or undefined. So it's a special point. It's where your derivative is 0 or undefined. And we're going to draw a few little sketches there. It doesn't need to be an elaborate picture, but just so you can get the idea of it. If you have a parabola like this, do you see how I can draw in a tangent line with a 0 slope right there? That is a critical point. How else could I draw a parabola and get a critical point? Upside down. So also like this, I can draw in a tangent line with a 0 slope, and then that point of tangency, that's a critical point. Now you can get one even if your graph doesn't turn around. This is your cubic graph. Right there in the middle, you get a horizontal tangent line, but the graph doesn't necessarily have to turn around. It's still a critical point though. You didn't get a maximum or a minimum out of it, but it's still a critical point, still counts. And then there are a couple ways you can get undefined. There's one parent function. I want to see if you guys know it, where you could get, which one? Irrational. No, that one's all disjointed. It's kind of like a parabola, but it's not like a nice smooth one. I'll just go ahead and tell you. It's the absolute value one. Oh, did you say that? Oh, you kept it to yourself. So this is a critical point. You can't draw in a 0 tangent line. You can't draw in a horizontal tangent line, but that would still count as a critical point, that sharp edge there. And then the other way you can get undefined is with a vertical tangent line, because by definition, a vertical line has an undefined slope. Derivative means slope. I bring that up. Derivative means slope. Derivative means slope. Like if you aren't sure what to do, derivative means slope. All right. This is an undefined slope thing. And this is what I was getting at with that position graph that we just looked at. If your function is increasing, that means your derivative is positive. Think about going from McDonald's to Cookout. That's the scenario that you guys made. I didn't record that part though, so everyone that's watching the video talking about McDonald's and Cookout is super confused, but that was the story we made up about the graph. And if the function is decreasing, that means your derivative is negative. So I like to color code the positives and the negatives, but you need to be really careful about mixing up the words increasing, decreasing, and positive, negative, because they mean two different things. Okay, they go together and they're related, but they mean two different things. All right, so for each of these, we're going to state the critical points, label them as a relative maximum or minimum, or neither. They could be neither. And then sketch the graph of the derivative. That's what our objective is today, is to sketch derivative graphs. We're going to sketch them. They're not going to be perfect though, okay? So where do we have a critical point on this graph? So 0, do you see that right there? You could draw in a horizontal tangent line. And does that give us a relative maximum or minimum? All right, so we're going to say relative minimum at x equals 0. That is our critical point. And so when you go to sketch your derivative, and again, if you're a very type A person, you're going to have to take a few deep breaths and go with this, because it's not going to be perfect. It's going to be good enough. It's going to be good enough. It's a sketch, all right? So the only point that you can put on here specifically is 0, 0. You have a 0 slope at 0. Now here's where I'm going to color code. I'm going to use purple and green, but it doesn't matter, whatever colors you have. What is this graph doing first as I trace along? All right, decreasing, which means that our derivative should be negative, which means below sea level. That's what I always say, is below sea level or above sea level, okay? And then after that, this graph, I'm going to change to green here, is increasing, and that means my derivative should be positive, meaning above sea level. I'm sorry that the colors don't show up real great on the projector, okay? But that means we want to be below, go through that point at the origin, and then be above. So like this. That was real hard, wasn't it? Below the x-axis, below sea level, go through the point, and then above. Cool so far? always start with an easy example, but sometimes, do you know how things can get so easy that they're actually more difficult because like nothing happened? I feel like that's one of those. Okay, so let's try another one. There are actually two critical points in this one. Can you tell me where one of them is? -2 is one of them. Do you see that there? And that gives us a relative maximum. All right, so relative maximum at x equals -2. And then where's the other one? At 1. And so we're going to say relative minimum at x equals 1. So when you go to sketch your derivative, the only specific points that you get to plot, the only ones that actually are perfect, are that you get a 0 slope at -2. So I get a 0 at -2 and at +1. Those 2 points there are the only perfect points we're going to do. The rest of this is like, good enough. So I'm going to color code again. I'm going to start with my purple. I did purple as decreasing on this one, so I'm going to try and be consistent with that. So I am decreasing for this center part, the -2 to 1. I want my derivative to be what? Negative, meaning below the x-axis. And then for the sections where my graph is increasing, we want the derivative to be positive. So before I draw it, let me wait till everybody's done. I want you to watch me point to this. We want to be above, below, above, and go through those 2 points. So just watch, because if you look away, you're going to miss it. You want to be above, and then below, and then above. How far down does this go? No idea. It's good enough. Above, below, above. What? One more time. Yeah. So do you see how this graph is increasing, decreasing, increasing? Decreasing, increasing. That means you want your derivative to be above the x-axis, below the x-axis, and then above the x-axis again. So you want to be above until you get to -2. So that's this part. And then you want to be below for the part in between them. So below sea level. And then above. You're playing connect the dots, but just staying on the correct side of the x-axis.
Does it matter what, like, I guess, type of graph you're drawing it, or as long as it's just...
I'm going to get to that at the end.
Okay.
All right. Can anyone tell me a critical point? Okay, so we're going to say relative maximum at x equals 1. Good. Where else? 3. Good. So relative minimum at x equals 3. Actually, one more. Good. So neither at x equals -2. It's still a critical point. We just didn't happen to get a maximum or minimum out of it. Critical points are potential locations for maximums and minimums, but you may or may not get. So I'm going to color code again. I'm going to stick with what I did on the other side of the paper so I don't confuse anybody. So purple, again, is going to be my decreasing. That's where the derivative will be negative. And then green is going to be my increasing, and that's where the derivative will be positive. This is fun. It's like artwork in math class. Doodling. The other lesson I really like a whole lot is in pre-calc, or actually in algebra 2, I guess. Do you remember where you do the polynomial graphs? Does it wiggle or does it bounce off? I love those. They're just little doodles. This reminds me of that. All right, so when you go, I was just chit-chatting to give everyone time to finish. I don't want to rush anybody. All right, so the only specific points we can plot are the critical points, and those are where you're getting 0 slopes. Do you get what I'm saying? Like, do you see how these are horizontal lines here? Do you guys understand what I'm saying? Horizontal, 0 slope. That's why there's zeros over here. So we get one at 1 and 3 and -2. And again, I'm going to pause here until everyone does that. And I want you to watch because it takes only a second to draw it. And if you like look away, you're going to miss it. We want to be above, touch that critical point, and then still be above. So we're going to be above, above, below, above. Some of you are confident you're going and drawing it already. You want to draw it and then see if yours matches mine? You can do that if you want. You want to be above, touch that point, stay above, and then go below and then above. Yeah, now you can't go through the x-axis at any points other than the critical points. So like you can't touch the x-axis anywhere except at those 3 points. That's it. Yeah, those are like your gateways, point of entry. All right. So looking at this one, absolute value. You do get a critical point, even though it's not a zero slope, it's where the derivative is undefined. So we get a relative minimum at x equals 0. Now, here's the unfortunate thing. You can't put a point at 0, 0. This is not a zero. Don't write this on your paper. This does not make any sense. You cannot do that. Okay? Undefined means you don't get a point over here. So there won't be one. So you get precisely nothing, okay? Let's color code. We are decreasing. So derivative should be negative, and then increasing. So derivative should be positive. Now, remember how I said it's going to be like, good enough? This is one where you actually can plot specific numbers because you're doing slope. You're plotting slope. What is the slope of this line? -1. And then what's the slope of this line? +1. So don't do it yet. A lot of you are like trying to get ahead of me. Watch me do this first. You're going to be here at -1, but you can't put a point there because it's undefined. And then you're going to be at +1. So -1 and then +1. Now I wasn't here for this, but if you all used my notes, it should have been on there. I used these graphs back in unit 1 when we talk about limits so that when we get here, they aren't unfamiliar. That's the derivative graph of an absolute value is what those are. I saw your hand first though. Nope. Okay, go ahead.
So I think why can we put a point on this graph but not?
That's a really good question. So over here, do you see how this is a nice smooth curve? If I were to draw in tangent lines, don't do this, I'm going to ruin my paper here, but do you see how if I draw in tangent lines and they slowly get closer and closer, I can get one at 0 and then they go back up again. But here with that sharp edge, and we're going to talk a whole bunch about this next class too, but that sharp edge, you can't get a 0 slope here because this is specifically a slope of -1 and this is specifically a slope of +1. So you can't. This doesn't work. You just can't. It's such a crap answer, but I mean, do you see what I'm saying? Like with the slopes, they don't bend, so you can't do that. All right, so looking at this one, and what graph is this? Do you guys know which one this is? Exponential. Is there going to be a place where it actually goes horizontal? No. So guess how many critical points you get over here? 0. None. So here, let's just write no critical points. Because it has an asymptote, but it won't ever actually touch it. It's going to get closer and closer, but it will never actually go horizontal. So there are no critical points. All right, let's color code. What is this graph doing? Going up, increasing. So the whole thing is increasing. So we should always be above sea level. Our derivative is always positive. And again, you're going to have to watch. This is a very like, you must watch me lesson. I don't have a better answer than like, hey, look, okay? Do you see how if I draw in tangent lines, their slopes are very, very small. Do you see how as I go along and I draw in more tangent lines, what's happening to their slopes? They're increasing, they're going up, 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 up. So here is what your derivative graph is going to look like. It's going to start out very small, close to 0, and then go up, 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 up. The derivative of e to the x is e to the x. It's itself. Isn't that cool? Exponential is just the best function. So looking at this one, actually, do you know what this is the graph of? Yeah, it is either sine or cosine. Good job. Which one is it? It is sine. The way you can tell is it starts where? At 0, 0. Okay, so sine starts at the origin. Do you remember where cosine starts? At 1. Good, perfect. All right, I love it. So you're going to have an infinite number of critical points because it's going to keep waving forever and ever and ever. You all passed pre-calculus. It's okay. All right, so we're going to say relative maximums at, now where is this first one? Pi over 2. Relative maximum at pi over 2. And then every cycle of the unit circle, you're going to get another one. So how far is it the whole way around the circle? Okay, so good job. So you're going to put plus 2 pi n. So every 2 pi, you get another one. And then you're going to say relative minimum at, where is this first relative minimum? I'm pointing at it. Or well, we always start with the first positive one. 3 pi over 2. Good job. And again, every cycle of the unit circle, you get another one. So they're infinite. You have an infinite number of them because the graph keeps waving and waving and waving. All right, so when you go to do your derivative graph, each tick mark is going to be a pi over 2, okay? You can label all of them if you want, but can you just understand that each one is a pi over 2? Good there? Okay. That wasn't as enthusiastic as a response as I wanted, so I'm going to label them. At least the first 3. Now you're going to have a lot of critical points. You're going to have a lot of zeros over here. You're going to have pi over 2 and 3 pi over 2. And then I would have the next one over here. I kind of ran out of space, but basically every other tick mark. And then we're going to color code. So again, I'm going to make my decreasing my purple. That's where your derivative should be negative below sea level. And then my increasing is green. That's positive. So you're going to go negative, positive, negative, positive, negative, positive, negative, positive forever and ever and ever and ever and go through all of the points. You just have to make sure that you start at the right place. So we want to be positive, meaning above sea level, in between negative pi over 2 and positive pi over 2. So watch me do that. Again, you got to watch because I don't have a better explanation than halo. We want to be above sea level in between these 2 points. So I know I want this part to be above. And then from there, you can just make it wave. You want to be below and then above, below, above, below, above, below, above forever. And oh my gosh, the derivative of sine is cosine. Isn't that interesting? So next unit, when we get into what all the derivative rules are, I've already taught you 2 of them. I always like to do that, like foreshadowing. So like when we get there, I already sort of showed it to you. So the derivative of e to the x is e to the x. Good, you already learned that one. And the derivative of sine is... Cool. All right, now this is what you were asking about a little bit earlier. I'm going to tie it all together here at the end. What happens to the... what is a degree? Let's first say that before I'm... Yeah, the exponent, the biggest exponent, the one that's like who's in charge here. What happens to the degree every time you take a derivative? Well, let me just look. Just look. This is a quadratic. The derivative is a line, linear. This is a cubic. The derivative is quadratic. So what happens to the degree when you take a derivative? Goes down by 1. Okay, so goes down by 1. And so I just want to write the order of them for you. So starting with cubic, the derivative of a cubic graph would be a what? Quadratic. The derivative of quadratic would be linear. And the derivative of linear I know this is where, like, it got so easy, it got more difficult.
Nothing. Zero.
What kind of line?
Zero.
Constant, good. I've got one more. The derivative of constant
Nothing.
is 0. And I'll even tie it back to the graph that we looked at the beginning. Do you remember we looked at this? What's going on right here? Your velocity is 0 because you're not moving. Okay, so that's the order that it goes in. So if you have a polynomial, if you take enough derivatives, you will eventually get down to 0.